AC and MC cables are both viable options for installations in locations such as open parking garages, under permanent awnings or breezeways, and beneath overpasses, provided they are installed correctly. AC cable is constructed with an aluminum conductor surrounded by a thermoplastic sheath on each individual conductor, further protected by a metal interlocked armor. MC cable, or metal-clad cable, features a flexible metal sheath encasing the individual conductors, which are also covered by a jacket. Both AC and MC cables offer moisture resistance, enabling them to withstand exposure to environmental elements. However, MC cable generally exhibits greater durability and resistance to physical damage. When installing either AC or MC cable in these semi-exposed environments, several key precautions should be observed. Firstly, it is crucial to ensure that the cable is adequately supported and protected against potential physical damage. This can be achieved by utilizing a cable tray or a similar support structure to prevent sagging or undue stress on the cable. Secondly, any openings or breaches in the cable jacket or armor must be meticulously sealed with a suitable sealant. This step is essential to prevent moisture from penetrating the cable and causing corrosion or other forms of deterioration. Thirdly, if the cable is likely to be exposed to direct sunlight, it is advisable to opt for a cable with a UV-resistant jacket. This will protect the cable from the degrading effects of ultraviolet radiation, prolonging its lifespan. Neglecting these precautions can lead to premature failure of the cable. For instance, an AC cable installed in a parking garage without proper support may sag over time. If this sagging cable then rubbed against a concrete beam, the armor can become compromised, allowing moisture ingress and subsequent corrosion. Similarly, an MC cable installed under an awning without proper sealing can allow moisture to enter through any breaches in the jacket, leading to corrosion of the conductors and potentially causing a short circuit. These examples underscore the importance of adhering to best practices during installation. Ensuring proper support, sealing all potential entry points for moisture, and utilizing UV-resistant cables when necessary can significantly extend the lifespan and reliability of AC and MC cables in these environments. Several factors contribute to the selection of AC or MC cable for a specific application, including cost, ease of installation, and the level of protection required. AC cable is generally less expensive than MC cable but may be more difficult to install, especially in tight spaces or complex runs. MC cable, while more expensive, offers greater flexibility and ease of installation. The choice between AC and MC cable also depends on the specific environmental conditions. In areas where the cable is likely to be exposed to significant physical abuse, such as in a high-traffic parking garage, MC cable's superior durability makes it the preferred choice. In less demanding environments, AC cable may be sufficient, provided that it is properly protected. From an electrical code perspective, both AC and MC cables are permitted for use in these locations, subject to certain conditions. The National Electrical Code, or NEC, provides detailed requirements for the installation of electrical cables, including those used in outdoor or wet locations. It is essential to consult the NEC in any applicable local codes to ensure that the installation complies with all relevant regulations. Some specific NEC articles that may be relevant include Article 320, which covers AC cable, Article 330, which covers MC cable, and Article 300, which contains general requirements for wiring methods. These articles address issues such as cable support, protection from physical damage, and grounding requirements. In addition to the NEC, local building codes may also impose specific requirements for electrical installations. It is important to check with the local authorities to ensure that the installation meets all applicable codes. The proper selection and installation of AC and MC cables are crucial for ensuring the safety and reliability of electrical systems in open environments. By following the precautions outlined above and adhering to all applicable codes and regulations, electricians can minimize the risk of cable failure and ensure that the installation will provide years of trouble-free service. Furthermore, regular inspection and maintenance of electrical cables can help to identify potential problems before they lead to failures. Cables should be inspected for signs of damage, such as cuts, abrasions, or corrosion. Any damaged cables should be repaired or replaced promptly. In addition to visual inspections, electrical testing can be used to assess the condition of cables. Insulation resistance testing, for example, can detect degradation of the cable insulation, which can be an early warning sign of potential failure. Thermographic imaging can also be used to identify hot spots in cables, which can indicate loose connections or other problems. By implementing a comprehensive inspection and maintenance program, building owners and facility managers can proactively address potential issues and prevent costly downtime. Ultimately, the longevity and reliability of AC and MC cables in open environments depend on a combination of factors, including proper selection, careful installation, and ongoing maintenance. By paying attention to these details, electricians can ensure that these cables provide safe and reliable electrical service for many years to come. It's worth elaborating further on the importance of proper cable support. When cables are not adequately supported, they can sag, which puts strain on the conductors and insulation. This strain can eventually lead to cracking or other damage, allowing moisture to enter the cable. In addition to sagging, improperly supported cables can also be vulnerable to physical damage from impact or abrasion. For example, a cable that is hanging loosely may be struck by a vehicle or other object, causing damage to the armor or jacket. The NEC provides specific requirements for cable support, including the maximum spacing between supports. These requirements vary depending on the type of cable and the installation environment. It is important to consult the NEC to determine the appropriate support requirements for a particular installation. Cable trays are a common method of supporting cables in commercial and industrial applications. Cable trays provide a continuous support surface for the cables, which helps to prevent sagging and protects them from physical damage. Cable trays are available in a variety of materials, including steel, aluminum, and fiberglass. The choice of material depends on the specific application and environmental conditions. Another important consideration is the type of fasteners used to secure the cables to the support structure. The fasteners should be corrosion resistant and compatible with the cable jacket material. It is also important to ensure that the fasteners are properly tightened to prevent the cables from slipping or moving. The type of sealant used to seal openings in the cable jacket or armor is also critical. The sealant should be compatible with the cable jacket material and should provide a watertight seal. There are a variety of sealants available, including silicone-based sealants, polyurethane sealants, and epoxy sealants. The choice of sealant depends on the specific application and environmental conditions. Silicone-based sealants are generally resistant to moisture and temperature extremes. Polyurethane sealants are more durable and resistant to abrasion. Epoxy sealants provide the strongest bond and are often used in demanding applications. When applying the sealant, it is important to follow the manufacturer's instructions carefully. The sealant should be applied to a clean, dry surface and should be allowed to cure completely before the cable is put into service. In addition to sealing openings in the cable jacket or armor, it is also important to seal any penetrations through walls or floors. These penetrations can be a source of moisture ingress and can also allow pests to enter the building. There are a variety of sealants and fire-stop materials available for sealing penetrations. The choice of material depends on the size and type of penetration and the fire resistance rating required. UV-resistant cable jackets are made from materials that are designed to withstand the damaging effects of ultraviolet radiation. UV radiation can cause the cable jacket to crack, fade, and become brittle. This can lead to moisture ingress and premature cable failure. UV-resistant cable jackets are typically made from polyethylene, polypropylene, or polyvinyl chloride compounds that contain UV stabilizers. The UV stabilizers absorb the UV radiation and prevent it from damaging the cable jacket. When selecting a UV-resistant cable, it is important to consider the level of UV exposure. Cables that will be exposed to direct sunlight for extended periods of time should have a higher UV resistance rating than cables that will be shaded or indoors. In addition to UV-resistant cable jackets, there are also UV-resistant coatings that can be applied to existing cable jackets. These coatings provide an additional layer of protection against UV radiation. The NEC requires that cables installed in wet locations be listed for wet locations. This means that the cable has been tested and certified to withstand exposure to moisture. Cables listed for wet locations are typically constructed with moisture-resistant materials and have a watertight jacket. The NEC also requires that cables installed in hazardous locations be listed for hazardous locations. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. Cables listed for hazardous locations are constructed with special materials and features that are designed to prevent ignition. In addition to the NEC requirements, local building codes may also impose specific requirements for electrical installations in wet or hazardous locations. It is important to check with the local authorities to ensure that the installation meets all applicable codes. Properly installed and maintained AC and NEC cables can provide years of reliable service in a variety of environments. By following the precautions outlined above, electricians can minimize the risk of cable failure and ensure that the installation is safe and compliant with all applicable codes and regulations.